Alright class, this video is for chapter 10 from your book, which talks about foundation and floor systems. So briefly, we're going to discuss some of these ideas that you need to be aware of um, when you're reading foundation plans and also drawing them or understanding the concept of foundations and floor systems. Well, first of all, you need to understand or be aware of that the foundation or good foundation design is crucial for the stability of the building. That's all the weight coming down from the building being transferred down through the walls or through the support members and being transferred all that weight down to your foundation, and then from the foundation, how is the soil going to support um, that weight coming down. So it's very important for you to understand the concept. And if we look here at the book, there's some stuff I want to touch on, and then I will have some images to show you. Before we get to this section, let me see. There we go. There you go. Foundation systems. Before we go there, or we look at the actual foundation systems, I want to talk about soil considerations. You need to know uh, before you design a foundation, or you think of what type of foundation you might need for your building. You need to be aware where is it that you're building or erecting your building. The soil, you need to know what's underneath the ground. You need to know if the soil is stable enough to support your building. It makes a big difference if you design a foundation system for here where we live, South Texas. Is way different if you're designing for someone that is going to build up in Montana or in New Mexico or even here at the beach. So the soil makes a big impact on your design of your foundation design. So you need to know what's underneath. Remember, with all that weight coming down from your structure, it's coming down all the way from the roof, transferring down to the support members, going to your foundation. The foundation is being supported by the soil. So you need to know what type of soil do I have? Do I have if it's is it uh, can it sustain my building? Okay, now of course the higher you go, the deeper you want to do your foundation because it's holding. So let me show you some images here that talks a little more on this. It says soil testing here on your book, and there's something called geotechnical soil test. You might want to do, or you well not do. Maybe you're building or you're not building, but you might need to be aware of what's underneath the soil, what's in the soil of the area where you want to build. So it could be that you just look at it and look stable, but you don't know what's underneath. So for those instances, it's better to get a report from a geotechnical soil test or get a geotechnical soil test and then look at the report to see what's under the ground. So what they do this test. They shove this members down, and it's like a straw sort of um, a member where as they're shoving it down with pressure. You can see it here. All the soil is going in to this tubular, I don't know what it's called, rod. Um, and then once they go deep, they can go deep like 20 feet, 15 feet, depends on, I guess, on the area. And then what they do, they open it up and then look at the soil. Okay, so they know exactly what's underneath. So, for example, let's look at this picture. See, they take it out and then they study it and they measure it. Okay, so we have clay, we have sand, we have all the different types of soil that you might have, and this tells you. And then they run a report and they tell you, okay, it's feasible to not just feasible, but this is what's underneath your where you plan to do your building. So take that information into consideration so you can design the foundation that it's going to support that building. Okay, so it's very important. Um, and I'm going to show you some pictures of a building, of a church that we built, a church that I go to. And we decided to have a soil test done just to be sure, to be on the safe side. You don't want to build and put all that money into a building and then later on for your foundation to crack because maybe there was something underneath. Maybe there was a lot of sand underneath. You're like a couple of feet down. It was a lot of sand, or there was a water table, which or closer water table to the surface, which we're gonna talk next. So it's very good to have a test done. Okay, that you know exactly what's underneath, and then the engineer, the structure engineer, is gonna design your foundation with all this information in mind. Okay, so geotechnical, you want to do that first. Okay, so take this back. All right, so do some soil testing, and they'll give you a report where it is. Um, Freezing, just be aware. The one of the issues that can mess up your foundation, it's the or concrete or foundation, is that when it gets cold, it freezes, so it compacts the foundation, and then when the summer or comes, it'll thaw it, and that compressing and thawing is going to weaken the foundation. So for some instances, like up north, there's some guides or some regulations that they have where you have to have the foundation deeper or X amount of feet lower than the freeze line, and that you will get. They have standards for that. So just to prevent the foundation to crack and for the building to come down or start cracking everywhere. So freeze line, just keep that in mind. Just you can do a short research on that so you can get more on that. Water content. We all know there's water underneath the ground, right? There's something called water table. And let me bring this image now, or this image is in. I just put water table foundation. You don't want to get to an issue of something like this, where you start building, you start excavating, and then you just have a pot of water sipping into your building because the water table, it's too close to the surface. Okay, if you would have done a geotechnical um, test, they'll catch this. Let's say they'll go like 5 feet underneath. There's a lot of moisture. There's a lot of water. We picked up, but when they pulled it up, there's a lot of mud in a certain section. So that's telling there's water going through. Okay, so that's one of the reasons also you might want to do that test, the geotechnical test. So you don't want to get to these issues. Okay, so that's water going in, and the water table is too close to the surface, and so that water is just sipping in. It's coming up. So water table, we all know from the years we went to elementary about water tables. We know that there's water underneath us. There's like underground rivers. I don't know if there's an image here that run underground. Okay, that's what we have wells, right? If you have a well, you're picking the water from somewhere, and it's underground. There's rivers that go underground. So the water table, it tells you how high the water or how close the water is to the surface. Okay, now the water can be maybe 20 feet down is where the water is going, or it could be that it's 5 feet where the water is going through. And water, of course, we don't mean it's just like a stream of water. It's just water that is running through tiny rivers, you want to call it like that, or like veins that they're running to the ground, underneath the ground. So you need to find that. You need to find that out first, because you don't want to have issues with water content on your foundation. Now, what might happen? Well, this might happen, or it might happen that if you have some water, the water table is too close, it might weaken your foundation. You might have some water coming in from the bottom, causing some damages, or sipping into the side and causing some damages. And you don't want to have that, okay? Especially if you have like a basement. Well, of course, here we wouldn't have that much. But up north, if you have a basement and the water table is too close, then you can, there we go. Then you get this, you get into these issues here. Okay, there's moisture, and you get into moldy issues, which something you don't want to have. Okay, because the water is the water table is too high, and so that water is sipping in little by little, and it's bringing in the moisture, and then you have, there you go. There's more here, like issues like this. You of course you want to avoid, not only because of the mold, but also because it's gonna weaken. There you go. It's gonna weaken your it's from a crawl space. It's gonna weaken your foundation or foundation wall. Okay. So water table is very good to know the water content. What's underneath? Like how close is the water to my to where I'm gonna put my foundation. So I have to know those issues before, or those things you have to have them resolved before you um, start building. Now, uh, once they find out where the water table is, and if it's too close, then there will be a call for the engineer to design a system to prevent that moisture coming into the foundation. So that you just need to be aware of what it is, what it does, the cost, the what it might cost you if the water is too close or you have a lot of water content close to your foundation, and then the engineer is going to do all the work and trying to figure out what to do with it and how to avoid what system he needs to design or she needs to design to prevent that water content coming to and close to your foundation. Okay, because it will mess it up. Let's go here. Piling. I'm gonna attach a I'm gonna not attach. I'm gonna have a link. Um, and if you're watching this video, there's probably a link next to this one, and it's a video from it's a guy from YouTube. It's a contractor. Has a very good video on piling. I'm gonna just watch that link. It is very 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 interesting, or not interesting. It just tells you exactly what piling is. For example, if the soil or your foundation, there's the sand, there's a lot of soil that it cannot support your building, and maybe bedrock is about I don't know 20 feet down, or this is more like in areas where there's a lot of humidity. Okay, where there's a lot of humidity, the soil it tends to be very not as stable. So what they do, they uh, let me look for a picture so I can show you. They do get those piles. Uh, they shove them down on the soil, of course. Let me bring it in. There we go. Okay. So look at this one here. Load of structure, pile cap, low density, medium density, high density. So when they do the test, they kind of figure out, okay, we need to go deep to provide support for the structure. This area of the soil is not going to support it. Okay, it's going to sink in. Then this section here, for example, it's a little bit better, but it's going to sink in. But they realize that down here, it's a very high density material, might be bedrock, that this can support this structure, the load. So these are the piles. They shove them down until they hit that support that it needs. So then this weight coming down from the structure is going through the piles and is being supported by this material, except this bedrock, that really supports or gives the support to the structure. Okay, so there's different ways of doing it, or that they do it. You can do a research on that. There's different ways of doing that, but that's basically what it is. All right, let's look at these. See, they go down. Like for example, if you watch a video when they did the Twin Towers, there's a documentary on YouTube. You might want to look at that. They had to excavate, I think, like seven stories down or 9 stories down to get to bedrock, because it's an island. Manhattan, it's an island. So they need to excavate so it can provide the support that the structure was going to need. But this is basically what it is. You go down until you find the support that you need, and these are the piles. These are probably shoved down. I don't know how much. Okay, but watch the video that it's right next to this one. It's very very. It explains it very well. Okay. Okay, so let me close this one. Let's see, what do we have next? We have the different types of foundation, or the footings. The footings are what's supporting the weight coming down. Okay, and here we have some samples. There are different types of systems. You can do a research on the different systems. The stem walls, right? They're the ones that pull up and they go all around. The footing could be just a footing supporting a column, or a member that supports part of the foundation. And I'm going to show you some pictures right now. Okay, but there's different types of foundations. And here it just goes over some samples that you can read on. Okay, we have some images here. See here we have this is foundation. Okay, this type of foundation you'll probably see it more up north. Okay, where you have a foundation wall or stem going down, and then this is where the structure is going to go. So the structure is it's coming down, and you see the bolts right there, which is going to tie probably the sole plate, and then from here it goes up. So all the weight is transferring down and going down right here. And then for this big spans they have there, more than likely, I don't know if there's going to be there. I don't know if they're going to put some stuff there, more than likely, and see how it's aligned with that section here and this one here. So it's probably that's going to support some member going across like that. Same thing here is going to support a member, and then they're going to have probably joists going the opposite direction. So there's different types of foundation systems that you need to look into. The one we do here at the Valley is the on grade. We call it slab foundation. So this is it's more feasible here for the Valley, for the area that we live in. But it's more the soil is it's supportive enough. There's the water table, it's not as high, and also the soil that we have it supports a slab foundation, and also it's a lot cheaper just to have it and pour it and you're done. And also maintenance wise, it's a lot better. You just pour it and the concrete's there, and you just that's it. You're ready to go. You don't have to go and look at the wood members if it get rotten, if you have some leakage or whatever. The slab foundation, it's what we use here. All right, so let's see. I'm gonna go over this, and I'm gonna show you some pictures that I have of a church that we built. All right, so and all this you can read on. It's the good thing with the book is very self-explanatory. Okay, like in this case, if you look here, it's a drainage. So this is the like well, the name escaped me, but all the water that sinks in, then they have this drain at the bottom, so it's gonna seep through there and it's gonna shoot through that area, so that it prevents the water seeping into your foundation. This is more of a basement sort of area here. Okay. All right. Let's see what we have here. You think of a pressure, and this is just more of a, I guess, more a common sense. Whenever you look at a set of drawings or a building or a design of a house, everything has to be cohesive, and it's not just lines that you're drawing. It has to make sense. So just keep in mind that there's a lot of pressure on earth, the soil pressure. So when you do some sort of foundation, it needs to be able to support the pressure coming in. Okay, so just keep that in mind. Also, the way you tie it down, you're tying down your walls to the foundation, has to be very sturdy. I'm not talking about this one. Very sturdy, because if, for example, we have hurricane winds, it's pulling the structure from the foundation, so that connection with the foundation and the structure has to be very tight so that it doesn't rip it off. Okay, and then also the foundation itself has to be very well designed so that it grabs, I guess, if you're going to use that word, to the soil, because as it's pulling, the structure is going to grab to the foundation, and the foundation is grabbing to the soil. So you just provide that support. Okay, and again, this, if you see it like in a more holistic way, it makes a lot more sense. All right, let's see. And then here are some plans of how to read them. Systems. I think this is where we want to get to. Not yet. Here we go. And I don't know how far am I. How many minutes? Oops, almost 20 minutes. I'm gonna hurry up. On grade foundation, on grade foundation, it's the foundation that they're built on the actual soil. Um, and the one we do is it's slab foundation. I think it's somewhere here. Okay. Now for slab foundations, and I'm going to show you some pictures of the ones we have. You can read on this. You can read on oops. You can read on the control joints, construction joints, expansion joints. Just read on that. It's very good information, but I don't want to explain. I don't want to. And also it shows you here what it does, or how to view it. Um, read on this too. I don't want this to get too lengthy. Okay, reinforcement. This is what I want to also show you. You need on your whenever you do a slab foundation, you're gonna put pour concrete. You need to provide the support for the concrete. The concrete is very good. It compresses very well, but when you expand it, it's gonna crack. Right? Let's just get a piece of just concrete poured I don't know, make a form that is about 2 feet and maybe 2 by 2, like like a rectangle of a piece of concrete. It compacts very well, but when you try to bend it, more than likely it's gonna crack. So to prevent that, you put a steel in between. Okay, and that's what's called reinforced slab or slab reinforcement. Is rebar going through it or wire mesh that it goes through it, and that's what holds it and prevents it from cracking. Now it's gonna grab to the rebar, and so it's gonna be a lot more sturdy. It's gonna give it a lot more sturdiness to the foundation. Let me show you some pictures. Okay, okay, they open somewhere else. Let me open them. Okay, I have some pictures here, and this is a church that we finished a couple of years ago. Um, so I got some pictures of the process. You notice here there used to be a house here, so we removed that. We got rid of it, and then the plans engineer had us or to I think remove I think it was 6 or 8 inches or maybe 12, I don't know, from the soil that we had. So here you can see the soil, the existing soil. You can see right here, and here are the marks of where the foundation work is going to go. And there's probably another one here, probably another one on this side. You can see it there, and they put the height. And then they go by the plans. The plan says I think it said to remove 8 inches or 12 inches, I forgot, or maybe 6. So what they're doing right now is removing all that dirt, getting rid of it. We're gonna pull it out. Okay, because according to the plans, we needed to bring a different type of soil to provide extra support for our foundation. So what they're doing here, they're just getting rid of all that dirt, leveling it, and then they were gonna bring the other type of soil that they required, which was more stable, and then bring that dirt in and pull it up a little bit higher, and then compact it very, very, very well, so they can actually do the prepare for the foundation. So here they're removing all the dirt, and then they were gonna pull more dirt. Once they remove this, they brought more in, compacted it, put it higher, and then they started doing the preparing for foundation. And I think that's the next picture. There you go. See all this dirt over here? That's the one that was removed, all that dirt. So everything that was removed, we had it up here. So in this picture, they already had removed all the dirt. They brought the soil in, they compressed it, and that's what's underneath this black film. That's what the soil they brought in. They compacted it very well, and then here they already had done the trenches. See, these are the footings. Okay, stem walls right there. You can see them, those dark areas, and it's all around. And then the engineer decided where to put this footings there, those stem walls to provide support. And then the slab, it's from this point to that point, from that point to that point. So if we didn't have any rebar here, and all this was just slab, concrete, that it was gonna be sitting on that black film, and then 4 inches up, or I think we did 6 inches up. With time, or you put a lot of pressure, so the span is kind of big, more than likely this concrete would have cracked, right, in between, because of that weight coming down, or just because it compresses and it will crack. So what do? You put rebar. Okay, so this is the rebar that the engineer decided that we needed, and I think he went a little bit um, on the safe side. When I spoke to the guy that did our foundation, he has a lot of experience. So he was telling me the engineer put I think it was number 6 or number 7 rebar. I forgot what it was. And he said usually you can go with a thinner one, and it'll hold. And he has the experience in the field. And he says so. You want to save some money? Go ahead and get. We can put the rebar that it's not as heavy as this one. But we decided to go with what the engineer had decided because he's the expert, and also it doesn't hurt to have that extra support. And not only that, but you don't want to you want to put some extra thousand into the project and make sure that it's done right. So this is what the mesh that they put in there with rebar, and then when they pour, I'm sorry, sorry for that. Um, this little I forgot what they're called, but they're pulling up the rebar so that the concrete could go underneath, and the rebar kind of stays in the middle of the slab, and then the concrete is going all the way around and is holding to this mesh and is providing that support. Okay, and then here on the footing, it goes down and you have some more rebar going through there that provides the support that it needs. Okay, so before they pour this is what we had, and of course you have the plumbing. I think in the book talks about the plumbing. Um, that they have to put all the rough in before they pour on the concrete. So they prepare it. Okay, the plumber has to come in and set it up, and then he'll leave. They'll pour, blah blah blah, and then he'll come back and do everything. He has to run the water lines and so on and so forth. Okay, and you see the form here. They form it first, and then they pour. And I think the next picture that I have here is they poured in the morning, and right now they're just polishing the concrete. This members here, I think they're putting them, or they're just aligning them. Here is where the structural members are gonna come down and provide or to be erected the columns, and you'll see them right now. Okay, so here they already poured, and so now you see how this finished floor height. It's I think the city required 18 inches above curb or 24 inches. I forgot. So now this is the height that we needed. So in case if it rains, we have enough. The water won't go in, or according to the standards of the city of McAllen. All right. So here they already poured, and they're just prepping it. They came back later and provided and did the control joints with a saw. They did that one, I think, at like 2 or 3 days after they poured, and you can read that on your book about control joints. But here the members, the bolts that were put in place, so the structural crew can come and start erecting the columns. And I think that's the next picture they have here. Actually, no. Here's where it already cured. As a matter of fact, I think you can see here. I think by now they already had done the control joints. I think they're there and they're there. I think it's here. It's too dirty, but I think they already had done the control joints. And you can read that on that. These are my kids. And we came back in the evening to check the process. And the last one that I'm going to show you, it's where they're actually now building or pulling up the members. So you can see now this everything that we have discussed about removing the soil, checking the soil, what's underneath, removing the soil that it was there, bringing new soil in, pulling it up, compacting it, preparing the foundation, putting the rebar, doing the footings, the deep that the engineer required, pouring the concrete to provide support for a structure. So now there's weight coming down. We're certain that this weight that we have here is gonna be supported by our foundation, and our foundation is being supported by our soil because we tested it. So that's the process you want to follow. Okay, you don't want to have issues where your foundation starts cracking, because then everything's gonna start messing up. Okay, so this is one of the projects that we worked on, and I had the privilege to be in the design group that did all the interior and also just manage the construction. So it was a very good experience. Okay, so that's slab foundation. I'm gonna just make it kind of go faster now because the time is flying by. So slab foundation, it's on grade, and you have seen these. Just drive around any construction site here in the area, and more than likely you're gonna see the slab foundation. Okay, and actually for the project, for the design, this is what we're gonna be. For the sketch, this is what we're gonna be doing. We're gonna do a slab foundation, so we're gonna have to show our footings, okay, and we're gonna show that with hidden lines. So whenever you see a slab, you draw it like this, like if you were seeing the concrete, like this. This is how you draw it on the set of drawings. But you have to show where the footings are, in other words, where these are underneath your foundation. So these are shown in hidden lines because the footings are underneath the slab. And when I do the other video, I'll show you how to do it. Okay, so this is the slab foundations, which is on grade foundations, and then you have the last one from the book, and it talks about crawlspace foundation, and these are the ones that we have. You see these systems more up north, more than anything because of the freeze line, and probably the soil too. So this is the type of crawlspace. You have crawlspace underneath, but of course you still have to provide the support. And here you have some just pictures of how that's done. So you have that cross spaces right here, and then you have your joist, and they being supported by different footings. Okay. Or yeah, this is the footing, and there's a system bringing it supporting the floor. Okay, so these are just some samples, but the cross space, you have some cross space underneath your floor. All right. And this is post and beam. I think it also talks about post and beam, and pretty sure we have seen these in some areas where they just do all the post, and then they use that and start doing the floor. Okay. So again, the foundation is going to depend on the area, on the soil that you might have. So it's don't think it's just one size fits all. You have to know you need to know the soil, you need to know the freeze line, you need to know words that you're going to design, so you provide the adequate foundation. Okay. I think I went over. I didn't want to spend too much time, so I apologize for that. So and then last thing, I want to show you what you want to avoid. You don't want to have issues with bad foundations because this might happen. You don't want to have issues where, I think on this one, there was a mudslide that came in and just hit it on the bottom, and the building just tilted and went sideways. And I think you can see there was another image. So you can see the piles here. See how deep they were, or I don't know if they were deeper, or they just went in a couple of feet down. So just think of you're trying to put, for example, a rod, or on the island you have one of those umbrellas that you went to the beach. You have some of those umbrellas you want to put up so you can enjoy your day at the beach. If you put it in about 2 inches into the sand, the wind is gonna come and it's gonna blow it to the side. If you want for it to be sturdy, you have to shove it in maybe a foot down or maybe a foot and a half. That way the wind comes, it's gonna support it. Well, same idea here. They had some piles here, maybe they were not deep enough, so this thing just tilted over. Or the material they used for this piles, it was not the adequate one, so when the pressure came, they just snapped and it went sideways. So imagine all this money. Hopefully there was no people in here, hopefully, but imagine all this money going to waste because of a bad foundation. Okay, so you want to avoid that. You want to avoid this type of issues. Whenever you see something cracking like this, it's a bad foundation. The foundation should be grabbed to the soil, and it shouldn't move. The house might move, but if it moves and the foundation is not adequate, the foundation is gonna crack. And once the foundation cracks, everything cracks. You'll see stuff like that. You'll see stuff like this, and you don't want that. That's a bad foundation system. Okay, So I just read over the chapter. Hopefully, I explained some of these uh, issues or some of these terms a little more in depth. But again, read the chapter. It's very thorough. And then I'm going to do another video showing how to do the actual sketch of your foundation. And we're going to do a slab foundation of the house that you guys are designing. Okay. So thank you for your time, and hopefully this video helped you understand a little bit better chapter 10. But go ahead and read it, and it's very, very thorough on the information. All right. So good luck and have fun.